Hey everyone, in this example we will be solving the rational equation you see on your screen right now. So to get this first example started, we want to factor our denominators because we're going to use the technique where we will clear out any and all fractions by multiplying everything by the least common denominator. And while multiplying, we won't actually jump right into expanding all these numerators, but instead we will reduce or simplify any matching factors from the least common denominator that we multiplied through by and the denominators of the existing rational expressions. So first thing I need to do is factor this quadratic trinomial all the way on the right, and chances are, because this isn't my first rodeo, is that the factors, or at least one of the factors that are used over here, are probably going to be my factors over there, but 8 and 4, they're kind of like, hey, we work. Come on, don't be stupid. So x minus 8, x minus 4, let's check that. First times first, x squared. Outer is negative 4x, inner is negative 8x, that makes negative 12x, and a negative times a negative does make a positive, and in this case, a positive 32. So winner, winner, chicken dinner. I'm going to draw a simple x crossing out the expanded denominator right there so I don't get too distracted. And on the side, I'm going to write down that my least common denominator of all of these expressions is in fact the product of x minus 8 and x minus 4. I'm also going to write down my restrictions. So restrictions are values for my variable that I'm going to rule out before I even get started. Sometimes I forget and I just do it at the end. I don't think that that's something I should be proud of, and I don't think that's a very good habit, so I definitely recommend you try to do that first. So our restrictions are the values of x in this case. That would make my fraction in any part of this problem undefined by creating a 0 in the denominator. How do you know what makes a denominator 0? Well, I'm glad you asked. I know this might seem obvious, but it isn't. You take the denominator, x minus 8, and you set it equal to 0 and solve for x. But since this is what we don't want to happen, I'm just going to do a little can't equal 0 situation. Add over the 8, and x cannot equal 8. Similarly, x minus 4, I also don't want to equal 0. Add over the 4, and x cannot equal 4. So these restrictions are important because if I finish solving this problem and it turns out that one of the answers I get by solving the equation is one of my restricted values, I will mark that answer as being extraneous, and we'll comment on that a little bit more in a minute. So I'm going to go ahead and draw my giant parentheses around this problem. I always would call using this similar technique on complex fractions making a hamburger. I kind of think about this as being a hot dog. I don't really have my whole full analogy worked out for it yet. It's a work in progress, but you know, it's long and skinny as opposed to the little hamburger, the little buns in the complex fraction examples on that set of problems, if you know what I'm talking about. Anyway, we're going to go ahead and multiply through by our least common denominator. When I'm extra lazy, I just do times and I write LCD, but I guess I can try to squeeze in just a smidge right here for us. So we're going to go ahead and write x minus 8 and x minus 4, and this little combo is boop, boop, boop going into everybody. All right. This goes in here. Now, some of us might benefit from a little bit more of a visual. So let's get to that. The x minus 8 and x minus 4, we shouldn't be writing this out on the numerator of every single rational expression in this rational equation. That's just ridiculous, okay? Instead, we kind of hold that picture in our head, which I do understand is quite difficult for some people. We hold that picture in our head while we work the problem out and consider what pieces reduce or simplify out and become 1 and what pieces stay. So I'm going to take this little paper here. I know it's a little dark, but I think it'll show up okay on camera. So this right here, right? That's your least common denominator. If we go over here and we multiply it, and to hang out with this guy over here, right? If this gets multiplied into that numerator, oh boy, which factors will reduce or simplify? Well, x minus 8 and x minus 8. So what will be left behind for you to be working with? Well, you'll have the x in the numerator and you'll have x minus 4. Lovely. Minus, now we're going to multiply it over here next to the 2. 2 times all this good stuff, x minus 8 and x minus 4. Well, what pieces will reduce here? The x minus 4 and the x minus 4. So what's left? 2 and the x minus 8. Yay! Equals, now this is over here in the numerator, x minus 8 and x minus 4. This, negative 3x plus 56, please make sure we put parentheses around that. If this is over here, right, what happens? Well, look at that. Both of these reduce with both of those. Yay! So what's left behind? Just negative 3x plus 56. So I'm not going to do this ridiculous little paper thing all of the time, but I thought it would be a cute little help getting the ball rolling on this example set. So now the next thing I'm going to do is, while solving this rational or ratio or fraction type equation, which is consists of polynomials for numerators and denominators, by doing this technique and multiplying through by the least common denominator, it turns into a polynomial equation. Since polynomial equations have a domain of all real numbers, they're smooth, they're continuous, they don't have any asymptotes or discontinuities, answers are answers. It's no big deal. But really, we're just using a polynomial equation to help us solve a rational equation, which does have restrictions, right? So you can't necessarily have all of those answers. So it's like, you go into a database and you find everybody with a certain blood type because you're, looking for suspects for a crime or candidates for organ donation. I don't know. But certain people perhaps had an alibi, or certain people perhaps, can't be an organ donor, whatever it may be. So they get excluded. They're just extraneous matches. They worked out for the blood type, but they don't really match up with what we need them for. Okay. Hopefully that didn't make you more confused. So let's go ahead and just solve this lovely polynomial now as if it were no big deal. X squared minus 4x minus 2x. Please don't mess this up right here. It's plus 16 equals negative 3x plus 56. So I'm looking like I got a quadratic equation going on for me over here. So if we continue solving this quadratic, we will, and since it's a polynomial, we're going to strive to get it equal to 0, get it into standard form so that we can factor, right? We can factor and then apply the 0 product property and set each factor equal to 0. If it's not factorable, we will use quadratic formula or perhaps rational root theorem. No, that won't work, rational root theorem. What am I talking about? If it was factorable, don't listen to me. I don't know why I said that. So that would be useful if it was like, say, cubic and not factorable, right? Okay. Let's combine like terms. X squared minus 6x plus 16 is negative 3x plus 56. Got to get it equal to 0. So I'm going to add 3x and I'm going to subtract 56. But when I do this, I'm going to do this to both sides, of course, because you always keep balance when you're dealing with your equations. This right side, cancel, because this is 0 on this side. Yay, we're happy with the happy 0. This will become what? X squared. X squared Negative 6 plus 3 is negative 3x, and 16 minus 56. Well, if I just do 16 minus 6, I'm at 50. And then take away 10 more, or not 10 more, I took away 6 and I was at what? 16, take away 6, I'm at 10. I have to take away 50 more, so negative 40. I definitely just like inverted that, or maybe I did say it correctly, but I was thinking it incorrectly. I have no idea. Sorry about that. So I have this cute little quadratic that I am worrying about right now. X to the second minus 3x minus 40 equals 0. Now, is this factorable? Can you think of a pair of factors that multiply to give you negative 40 and that add or subtract to give you negative 3? How about 8 and 5? So when all is said and done, if you use the AC method and you split your middle term and you use grouping, press pause, please do that on the side. I know it's going to be with 8 and 5. I can use the shortcut only because the a, or the coefficient of the quadratic, is 1. Stop trying to do it when it's not 1. I've told you before, it doesn't work. Stop trying. What are you doing? Knock it off. X. So outer and inner, right? I need them to multiply to be negative 40. That means one of them is negative. For right now, I'm going to draw 2 minus signs. Anyone who's fast forwarding this video and looking at that might just be copying the 2 minus signs. I make a minus because it's very easy to turn a minus into a plus. Now, if I know 1 is positive and I know my middle term is negative, that means the bigger of the two numbers that has more power on the adding and subtracting will be negative. So that makes the 5 positive. To finish solving this example, we're going to implement that zero product property. We're going to set each factor equal to 0. So I'm going to get x equals 8 as one solution. And we're going to get x is equal to negative 5 as another solution. Now, while these work out, what were our extraneous solutions? Do you remember? Did you write it down? If you did write it down, and it's up on my screen up over here, but I cropped it out so that people have to be keeping up and paying attention. If you did, you'll know that one of these answers should have an arrow drawn to it, pointed, and written out the word extraneous. And the other answer is good to go. So maybe put a check mark next to it, or say, final answer, x equals blank. X equals other thing. Underneath, we write extraneous. You don't cross it, scribble it out, and throw it in the garbage. You indicate it is extraneous to really prove that you truly did solve the problem. All right? So I'm not writing that on the screen. That is for you to write down to prove that you are paying attention and listening. Please check out the playlist for 2 more videos at least, just like this example, that work out in their own way. And if you need to go back and look at the other types of examples, go back to the playlist for that as well. And the next one in the list of videos on the playlist should be popping up on the screen for you to click. All right. Hope you have a great day, and adios.